Today we're going to look at our exit exam measurement and geometry strand. As we look at these problems, we're going to be using our logic test-taking strategy. We could set them up and solve algebra problems, but sometimes logic is a better way to do the problem. So as we look at 1A, a wall is 3 meters high. About how high is the wall in feet and inches? So they tell us that 1 meter is equal to 39 inches. Now, since the answer is going to be in feet and inches, we should take the 39 and convert it into feet. And so you need to know that 1 foot has how many inches in it? So 1 foot is 12 inches. So how many feet are in 39? And so you could figure that out by dividing the 39 by 12. And so that means that we have 3 feet and 3 inches left over. So 1 meter is really equal to 3 feet and 3 inches. So the wall is 3 meters high. So what I'm just going to double it. So if 1 meter is this, then 2 meters would be 6 feet, 6 inches. And 3 meters, I'm just going to add another meter to this. So that would be 9 feet and 9 inches. So the correct answer here is B. Now at this step, I could have just multiplied by 3 and I would have got the same thing. So it doesn't really matter how you get there as long as you get the right answer. So try 1B now on your own. Jessica went running for 2 hours. How many seconds did Jessica run? And so we're just going to start by writing 2 hours. And so what we're going to do is we're going to make a conversion table. And we need to convert hours into seconds. Now, you may not know the conversion from hours to seconds, but you probably know that 1 hour is equal to how many minutes? 60 minutes. And now, so the idea here is that this and this are going to cancel, and so right now my unit is minutes. But again, I want my answer to be in seconds. So, to cancel out the minutes, I put 1 minute on the bottom, and how many seconds are in 1 minute? So that's 60. So now you can see that the minutes cancel out, and so now the unit is seconds, which is what I want. And so now I just multiply across. And so I get 2 times 60 times 60. So 2 times 60 times 60. And then on the bottom it's just 111, so we don't even worry about it. So 60 times 60 is 3,600. And then we got to multiply that by 2. And that would give us 7,200. So try 2B on your own. 3A, the actual width of a rectangle is 7 inches. So the actual width is 7 inches. Use the scale drawing of the rectangle to find the actual length. And so when you're given a problem like this, we're basically just going to write a ratio of the width to the length. And so in the problem, we're given that the width is 1.4 inches over 4.2 inches. And so when you have this fraction, the easiest thing to do is to reduce that fraction. And so whenever you're given a fraction that has decimals in it, we want to get rid of them. So if I move this one once, I have to move this decimal once. And so now that gives me 14 over 42. And now we'd want to reduce this fraction. So 7 goes into this twice. 7 goes into this 6 times. And then 2/6 can be reduced to 1/3. And so our ratio of our width to our length is 1/3. And so we're going to use that now to answer our question, because we know that the real width is 7 inches. And so you just need to remember that the width was on top. So I have to put the 7 up here. And then I'm going to figure out what the length is. And so when you have two fractions equal to each other, it's called a proportion. And the way you solve it is by cross multiplying. And so I get L times 1, which is just L, and 3 times 7, which is 21. So the actual length is 21. Now, if I were going to just try to use some test-taking strategies to eliminate an answer, look at this one here. This is 1.4 and this is 4.2. And they told us that this was equal to 7. And so I know it's not going to be A, because the length has to be bigger than the width. And I could probably guess it's not going to be B, because if this was 14, that would be double that. And if I were to double 1.4, I wouldn't get 4.2. And so I could actually get rid of those two answers. All right, try 3B on your own. All right, so at 4A, Jake is using a ruler and a map to measure the distance from Henley to Sailport. The actual distance from Henley to Sailport is 150 kilometers. What is the scale used to create the map? So we actually know that from here to here is actually 150 kilometers. And using the ruler, we know from here to here it's 6 centimeters. So again, we're just going to start with that idea of setting up a ratio. So 6 centimeters is the same as 150 kilometers, or is actually 150 kilometers. And we want to know what 1 centimeter equals in kilometers. So we could call that x. So we have this proportion again, and so we just cross multiply. And so we get 6x is equal to 150 divided by 6. So x is equal to, okay, so 6 goes in the 15 twice. Six goes into 35 times. So x is 25. So the correct answer is D. So try 4B on your own.